We're going to work one quick welding example problem, and I've got the problem already drawn here. I know it's not to scale, but I got to exaggerate the thicknesses so you can see them. But essentially I've got two 4-inch wide plates that I need to overlap, and I'm going to put a fillet weld. We'll just generally draw this on here in red and fill that in. So have a fillet weld on this side as well as we would have a fillet weld on this side. And so we would weld in both locations for this particular one. Note that the plates are a 1/4 inch thick and that the plates are made from A36 steel. For this particular problem, the textbook includes one example capacity chart for the allowable strength of a fillet weld. And it's pretty easy to utilize. It just gives us strength per inch of weld, and we're going to use that in this problem. So first thing we need to do is determine the size of the weld. We don't actually know that, and there's a handful of rules in your textbook that you would need to go through. So the rules on page 524 through 525 help indicate what size of weld we would actually need. I'm going to refer you to see rule number 1 and rule number 2. Those are the two that are most applicable for this particular problem. I'll let you read through those. It talks about the minimum size for the weld and how much difference the weld can be relative to the thickness of the plates. And essentially, if you read those rules, you'll discover that the weld size can be either 1/8 or 3/16 of an inch. And if we go to table 10.5, that's on page number 524 of your book. It only has a 3/16 inch option here. Either of those would be acceptable, but we'll go ahead and we will use the 3/16 option since that's within the book. The key here for these types of problems, at least the ones in the textbook, they're just serving as examples for how to determine what the welding capacity would be. And so you'd have to actually have a series of much more robust tables than this for different welding configurations, strengths of steel, etc. From table 10.5, we note that the load, whoops, wrong color. The load is equal to 2.78 kips per inch. This is just a capacity for how much load this particular size weld can actually handle. And so the next thing we need to do is simply determine the weld length. If we got 2.78 kips per inch, how many inches of weld do we have? Well, we've got 2 welds, and how long is each weld? 4 inches. So a total of 8 inches. And therefore, my capacity for this particular welded connection is equal to 2.78 kips per inch times the 8 inches for a total load of this connection of 22.2 kips. Now, this is where the textbook problems basically go to. They walk you through how to get the appropriate weld size that we would need. But the other thing to note is that we need to check the weld capacity against the plate capacity, because we want to know whether or not the weld will break before the plate or the plate will break before the weld. If the plate's gonna break first, then that's the weak link. But if the weld is going to break first, then we probably want to do something with the weld to make it stronger. That's why we're checking this. So we want to check the plate capacity. Two quick things to recall. When we talked about our bolts, we came across both of these. If we're talking about the tensile stress capacity, specifically for the gross plate, the allowable value was 60% of the yield strength. And the other thing that we could note is that as far as calculating the actual, if we took the load and divided by the area of the gross plate, then we'd also have that same tensile stress capacity. So also recall that the area gross, this is the easier one, is simply the plate width multiplied by the plate thickness. So if we set those two equal together and go ahead and solve for the plate capacity, we would end up with the plate is equal to the gross area. I've gone ahead and I've just substituted here. We'll just notate that real quick, that we're just multiplying the width and the thickness. That's the area gross. And we also multiplied that by 60% of the yield stress. And we'll actually just notate this underneath. Area gross. And this is the allowable tensile stress that we would experience. Let's go ahead and plug all our values in now. The width of the plate. Now note that the plates, as I zoom back up, the plates are exactly the same. And so we'll assume that one will break the same approximate time as the other one. If one of these was smaller, then we'd want to work with the smaller value. So the width in this case is 4 inches for both plates. The thickness for both plates is 1/4 inch thick. We've got our 60% of the yield stress. We already defined these plates to be 36 KSI still, and so we've got 36 KSI is our yield stress. Plug that through and we've got 21.6 kips is the plate capacity. We apply 21.6 kips to this connection and the plate will break. In conclusion, we've got a weld capacity of 22.2 kips, a plate capacity of 21.6 kips. Therefore, in summary, the plate capacity is less than the weld capacity. As far as checking the welded connection is concerned, the weld is stronger than the plate, and therefore this weld is sufficiently designed for this particular welding configuration.